Dear students, we are back with chemistry today. I am here, the principal of Shakthi Pre-University College, teaching you chemistry of 10 standards, how to excel in the particular chapter called carbon and its compounds. Carbon and its compounds was a chapter which was very difficult in the initial days of board examinations. Yes, but now the days is changed. We are entering into an era where the deleted portions are more than the portions to study. Yes, carbon and its compounds is a chapter which is full of structures, full of reactions. But for this academic year, the reactions are deleted, structures are to be studied. Now, very important thing which we all have to think about is how to study the structures of this carbon and its compounds chapter. Initially, let's begin with carbon and its compounds. I am going to begin with carbon and its structures first. Carbon, the atomic number of carbon is 6. We all know atomic number is nothing but you have nucleus of an atom around which you have the first shell, CK shell, which has 2 electrons. The second shell is having 4 electrons in carbon. I'm repeating, nucleus, around the nucleus there is first shell, CK shell, second shell is L shell. The first shell has 2 electrons, second shell has 4 electrons. Second shell and first shell are only present in carbon. The electronic configuration of carbon, if you ask me, 1s2, 2s2 and 2p2, where in the first orbit there is only s orbital, in the second orbit there are s and p orbitals. Hope this part is very clear. I'm going to rub this diagram and continuing with only this. Number of electrons present in the outermost orbit. You may have to note this down. I say this is valence electrons. What are these valence electrons? Valence electrons are the electrons present in the outermost orbit. The outermost orbit is the second orbit here. In the outermost orbit, there are 2 orbitals, s orbital and p orbital, where s orbital has 2 electrons and p orbital has another 2 electrons. So total number of electrons present in the second orbit is 4. 4 is called as valence electrons present in carbon. If you have a doubt, just write the electronic configuration of nitrogen with atomic number 7. I say nitrogen has electronic configuration 1s2, first orbit is completed. 2s2 and 2p3. Can I say the number of electrons present in the outermost orbit of nitrogen is 5. So the valence electrons present in nitrogen is 5. Talk about oxygen. Atomic number of oxygen is 8. 1s2, 2s2, 2p4. You can obviously see the number of electrons present in the outermost orbit of oxygen is 6. So valence electrons present here are 6. What do we understand from this? Valence electrons present in carbon is 4. Valence electrons present in nitrogen is 5. Valence electrons present in oxygen is 6. You all have studied in the lower classes what is octet rule. The octet rule says any atom which possesses 8 electrons is said to be stable. Can I say carbon has 4, nitrogen has 5 and oxygen has 6. To fill this particular orbital to be stable, 8 electrons are must. So 2 electrons should be added to oxygen, 3 should be added to nitrogen, 4 are required to carbon. So it is very clear. Valency is a concept which has to be remembered by everyone. Valency is nothing but number of electrons required to fill the outermost orbital. So p orbital in oxygen requires 2. So valency of oxygen is 2. Valency of nitrogen is 3 because p orbital needs 3 electrons. I say carbon requires 4. So it is very clear. Valence electrons present in carbon is 4. Valence electrons present in nitrogen is 5. Valence electrons present in oxygen is 6, whereas valency of oxygen is 2, valency of nitrogen is 3, valency of carbon is 4. Let's talk about another concept which is very, very important, from which you all will begin your studies of carbon and its compounds. Nitrogen, atomic number 7, 1s2, 2s2, 2p3. Valency of nitrogen is 3, as I just now told you. Nitrogen is in a situation of donating 5 or accepting 3. Which is easy? Donating 5 electrons or accepting 3? Obviously, you say accepting 3 is easy. So, nitrogen is always available as N-3. Oxygen, atomic number 8, 1s2, 2s2, 2p4 is just what we have written. Oxygen has to donate 6 or accept 2. If I ask you the question, what are you going to do? Are you ready to donate 6 electrons or accept 2 electrons? Obviously, your answer is accepting 2 electrons. So, oxygen is always available as O2 minus or O minus 2. Now, my sincere question and the connecting question to the chapter called carbon and its compounds. Carbon has electronic configuration which is 1s2, 2s2, 2p2. Carbon has to donate 4 electrons or carbon has to accept 4 electrons. What does carbon do? Whether carbon donates 4 or carbon accepts 4. If carbon donates 4 electrons, carbon should have the charge of plus 4. If carbon accepts 4 electrons, carbon should have a charge of minus 4. Whether carbon is ready to be plus 4 or carbon is ready to be minus 4. If I ask you this question, you already have studied this, but the answer is carbon doesn't accept electrons. Also, carbon doesn't donate electrons, where carbon tries to share the electrons. What is this sharing up of electron then? Sharing up of electrons, sharing electrons. Let's be very clear about this sharing electrons. Take an example of hydrogen. Atomic number 1, 1s1 is the electronic configuration of hydrogen. Hydrogen 1s1 is the electronic configuration of hydrogen. Say there are 2 hydrogen atoms. One hydrogen atom is here, another hydrogen atom is here. You all know s orbital can fill maximum of 2 electrons. So this hydrogen is thinking, I want an electron to be accepted. The other hydrogen is also thinking, it wants an electron to be accepted. But if this hydrogen, say this is the dot structure what I am going to write. See, there is 1 electron in the s1 orbital, there is only 1. I write this as H dot, which is nothing but 1 electron. This representation is called as dot structure of hydrogen, or I can say it is Levi's dot structure. Another hydrogen which is also having only 1 electron, if at all, this electron is donated to the second hydrogen atom. This hydrogen is not stable, because this is expecting 2 electrons. Another hydrogen is also expecting 2 electrons. But is it possible to donate this electron to the other hydrogen? Never possible, because if it is a bond, in humanity we say, if there is a bond between 2 people, both the people should be happy in the bond. Similarly, if hydrogen has to be happy with the other hydrogen atom, this electron should be shared. Sharing up of electrons means that this hydrogen thinks that both these electrons are mine. The other hydrogen thinks that both these electrons are mine. That is the condition under which these two undergo a bonding by sharing the electrons. I say sharing up of electrons between 2 hydrogen atoms will lead to a bond called as covalent bond. Can you see this bond? This bond is called as covalent bond. So can I term this as sharing up of electrons between the 2 atoms is called as covalent bond. Hope you are very clear. Let us talk about another example in the textbook what you have. I say oxygen, atomic number 8, third time I am writing this, 2p2 and 2p4. Can you tell me how many number of valence electrons present in this? Your answer will be obviously 6. If there are 6 number of electrons present in oxygen, can I say 1, 2, 3, 4, 5 and 6? There are 6 valence electrons present in this. Another oxygen atom, 1, 2, 3, 4, 5, 6. But what does octet rule say? Octet rule say that an atom must contain 8 electrons. Is it possible for this oxygen to donate other 2 electrons to this so that the first oxygen atom is happy? It is not a question of being one atom happy. It is a question of being both the atoms happy in a bond. That is why this is against the rule. So this is not possible. So by the time this oxygen decides, I'm going to share my 2 electrons with the other oxygen atom. This oxygen atom says, yes, I'm also going to share 2 electrons with him. So now think about this position. Can I say inside the circle what I have drawn? There are 8 electrons, including the 2 shared electrons of the other oxygen atom. This oxygen atom thinks that I am also having 8 electrons which are present in my own shell. Being with this particular situation, oxygen comes to a conclusion that we are doubly bonded between 2 oxygen atoms. The double bond between these two, both the bonds are called as covalent bonds because there are 2 electrons which are shared between oxygen and oxygen atoms. If you ask me, sir, another example for this, I say another example for this is nitrogen with atomic number 7, 1s2, 2s2, 2p3. There are 5 electrons which are called as valence electrons. The valence electrons which are present here, I say nitrogen 1, 2, 3, 4, 5. Another nitrogen 1, 2, 3, 4, 5. What is the situation if you think about this? Nitrogen says, yes, I need 8 electrons. I have only 5. So I am ready to donate or share. Donating will not justify me. I have to share 3 electrons. If I share 3 electrons, can you think how many electrons do I have with me? I have 8 electrons and I'm happy. Octet rule is satisfied. The another nitrogen atom also is thinking about the same. It is also happy because it feels that it has got 8 electrons. Octet rule is satisfied. Can I say 2 nitrogen atoms form triple bonds? All the 3 are covalent bonds. All the 3 are covalent bonds. And we say nitrogen molecule is formed. As you formed oxygen molecule and hydrogen molecule, you are going to form the molecule of nitrogen here. Dear students, these are the very important questions because the first half of your chapter is containing only about this. There is covalent bond formation. Let us talk about carbon. Atomic number of carbon is 6, 1s2, 2s2, 2p2. If you ask me how to write Levi's dot structure or electron dot structure, I say carbon has 1, 2, 3 or 4. Total 4 number of electrons. We can write it in this way. There is hydrogen atom which comes and says, as you know, hydrogen requires 1 electron to be shared. Another hydrogen comes and says that it wants to share the electron. Another hydrogen which comes and says it wants to share the electron. Another one comes and shares it. So hydrogen every time thinks that hydrogen is happy by getting 2 electrons each, whereas carbon thinks that it has got 8 electrons. So the configuration of carbon is very, very clear. Carbon is happy with the 8 electrons, the way it has produced single bonds called as covalent bonds. This is nothing but carbon with 4 bonds. I say this is methane. I say this is methane. This is how the covalent bond formation is done in the carbon compounds. Continuing the concept of forming the bonds, I say there is next important question which will be asked to the examination is catenation. What is catenation? Carbon has the capacity of forming, you can see this, these are all nothing but the dot structure of carbon. Carbon tries to form bonds with the neighboring carbon atoms so that millions of carbon atoms are forming a long chain of C-C. Carbon-carbon chain. Carbon-carbon chain, which is because of sharing up of electrons. I explained to you what is sharing up of electrons and covalent bond. Because of which we say a long chain of carbon is possible. The phenomenon is called as catenation. Very important question for 1 mark. If at all it is asked for 2 marks, I say there are 3 types of catenation which are possible. First type of catenation is, as you all have seen, this is a straight chain. I say this is a straight chain. Whereas the second case, where there is a very important concept, you get a branch. Can you see a branch? This is called as branched chain. And third one, if you ask me, this world of cyclic compounds is going to be very beautiful. Can you check? There are 6 carbon atoms which are going to form a cyclic compound. There are 3 kinds of catenation. More about this we'll let you know in future, but now at the moment you should know what is catenation and what is the types of catenation. First one is straight chain, second one is branched chain, and third one is cyclic chain. Hope you understood this. Going ahead with this, what are the next important questions? The very important questions of this particular chapters begin from this, the concept called as hydrocarbons. As the name itself says, hydrogen and carbon. How do you term hydrocarbons? Is nothing but compounds containing hydrogen and carbon are called hydrocarbons. Your petrol consists of hydrogen and carbon. Your diesel consists of petrol as well as your carbon, your hydrogen. Vaseline contains carbon, hydrogen. Naphtha contains carbon, hydrogen. All these are the best examples for hydrocarbons with different ratios of carbon and hydrogen. Now, let's begin with one by one. What are the types to study? First type, maybe in your schools, you all have studied what are alkanes. You have studied what is alkenes. You have studied what is alkynes. How to study these alkanes, alkenes and alkynes? I'm beginning with the smallest ones to prepare you well for your examination. Let's begin with the first one, what are alkanes? I say alkanes have the general molecular formula CnH2n plus 2. CnH2n plus 2. Where the number n, 1 is equal to meet, n is equal to 2, it is eat. I say n is equal to 3, it is prop. I say n is equal to 4, it is but. And n is equal to 5 onwards, everybody will know, because n is equal to 5, which means for pent, n is equal to 6 is for hex, n is equal to 7 for hept, n is equal to 8 for oct, n is equal to 9 for non, and it's equal to 10 for dec. So remember these things first. One is meet, second is eat, third one is prop, fourth one is but, fifth one is pent. Sixth onwards, we all know about it. Let's begin with the first one. I say when there is general molecular formula CnH2n plus 2. I say when n is equal to 1, substitute in the equation. N is equal to 1, substitute in the equation. I say C1 H2 into 1 plus 2. You know that if this C is 1, H2 into 1 is 2 plus 2, it becomes 4, CH4. The first alkane, which we all know, is having the molecular formula CH4. I say molecular formula is CH4 when N is equal to 1 according to the general molecular formula. The naming starts with N is equal to 1, it is meet. Since you know that this is alkane, the ane is added here, it becomes methane. The structural formula for this is one carbon atom. You all know the valency of carbon is 4. So always there should be 4 bonds. 1 hydrogen, 2 hydrogen, 3 hydrogen and 4 hydrogens. See, N is equal to 2. Put it in this formula. C2 H 2 into 2 is 4 plus 2, 6. C2 H6. Hope you understood. C2 because N is equal to 2. 2 into 2 is 4 plus 2. 4 plus 2 is 6. I write C2H6. The name ETH. I told you 2 stands for ETH. And the name ane, ethane. The 2 carbon atoms rest to balance the valency. You know the valency of carbon is 4. Every carbon atom should have 4 bonds. This carbon atom has 1, 2, 3, 4. This carbon atom has 1, 2, 3, 4. Write all hydrogens. 1 hydrogen, 2 hydrogen, 3 hydrogen, 4th one, 5th one and 6th one. 2 carbon and 6 hydrogens. Hope you all understood how to write the rest of the carbon compounds now. Yes, I will be going ahead. Next one, I'm going to the second one, that is alkenes. As you all know, the general molecular formula of alkane was CnH2n plus 2, whereas here this is CnH2n only. So it is very clear, if n is equal to 1, this is not going to happen, because if there is ene, the double bond between 2 carbon atoms is must. So I can't go with n is equal to 1, I say n is equal to 2, where the name becomes eth and ene should be added, I say ethene, and 2 carbon atoms, double bond is must. Valency of carbon is 4. Already 2 bonds are there for the first carbon, and other 2 are there already for the second carbon. If you put n is equal to 2 here, C2H4 is the formula. Yes or no? Yes. I say then there is C2H4 is ethene. Molecular formula of ethene is C2H4. 1 hydrogen, 2 hydrogen, third hydrogen, fourth hydrogen. See, n is equal to 3. The name should be obviously prop. To prop, we are supposed to add ene. I say this is propene. When this is propene, I know 1 carbon atom, double bond, the second one. The condition for the third one is only single bond. When there is single bond for the third one, I say this carbon is supposed to have 2 bonds, because already 2 are here. This carbon has 3 bonds, only 1, say hydrogen, hydrogen, hydrogen. This carbon has only 1 bond, 1, 2, 3, altogether 4. Count the hydrogen atoms, 1, 2, 3, 4, 5, 6. C3H6 is the molecular formula of propane. If you put n is equal to 3 here, C3H2 into 3 is 6. C3H6 is the molecular formula of propane. Hope you understood how to write alkanes. Let's go to the next one, which is very simpler than this. I say that is alkynes. Alkynes are actually triple bonded molecules of hydrocarbons. I say general molecular formula for alkynes is CnH2n minus 2. In this, everybody should know that the molecular formula of alkanes is CnH2n plus 2. Molecular formula of alkenes is CnH2n only, and molecular formula of alkynes is CnH2n minus 2. Let's begin. You know that n is equal to 1 is not possible, n is equal to 2 is possible, because it is eth and ine, where 2 carbon atoms must possess a triple bond, because the meaning of ine is a triple bond. Meaning of ine is a triple bond. I say these triple bonds are must between the first 2 carbon atoms. When left is only 1, I say this is C2H2 should be the molecular formula of ethine. Let's put it here. N is equal to 2. This is 2 into 2 minus 2. 4 minus 2 is 2. That means C2H2 is once again the molecular formula of ethine. Let's go ahead with n is equal to 3. Let's substitute first. C3H6 minus 2 is 4. C3H4 should be the molecular formula of propine. Let's start writing the structural formula. 1, 2, 3 carbon atoms. Triple bond between the first 2 carbon atoms. I say there is only 1 chance for this carbon, because already 3 bonds are here, next bond is here. I say there is single bond to the next 2 carbon atoms. Obviously you can think 1, 2, 3, 4 bonds. This carbon atom is completely happy. You can't put extra hydrogen here. Go to the next one. 1 hydrogen, 2 hydrogen, 3 hydrogen. Altogether there are 4 bonds now. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The molecular formula is C3H4. The molecular formula is satisfying. Hope, my dear students, you all have understood how to write the hydrocarbons, especially the 3 hydrocarbons what I have taught you today. One is alkenes, alkenes and alkynes. The next class, I'm going to teach you what are alkyl groups, what are functional groups. Say amines, say carboxylic acids, say aldehydes, say ketones. These are very, very important along with alcohols. There are aromatic compounds which I'm going to teach you, which will be very, very sure questions for your final examinations. Hope at this episode I have taught you something interesting and you will enjoy this and start practicing. Read the textbook line by line, understand what is covalent bond, write the examples for covalent bonds. After that, come to hydrocarbons. In hydrocarbons, you need to understand what are the different types of hydrocarbons you need to study. Practicing is very, very important. I have practiced only two, say ethane, say ethyne, say propine, say whatever is taught. Please carry on with the n is equal to 10, because n is equal to 1, n is equal to 2, n is equal to 3 is very easy to write. As you go down, the chain becomes longer. You need to practice that. If you start practicing that, you will be very much confirmed about writing the structures of hydrocarbons. With this, I hope you enjoyed the session and understood the session. See you in the next episode. Thank you.